Age Industries. Welcome to Scientific Explanations. Today we'll be covering the Rutherford gold foil experiment.
Ernest Rutherford was a New Zealand physicist who pioneered research and design in the field of atomic and nuclear physics. People call him the father of nuclear physics. His experiment, deemed the Rutherford gold foil experiment, was designed to test the accuracy of the plum pudding model of the atom.
The plum pudding model of an atom depicts the atom as a sphere of positive charge that contains negatively charged electrons. This was deemed the plum pudding model because it was reminiscent of how raisins are distributed in a plum pudding. It shows that the electrons are like the plums scattered throughout the pudding.
In this gold foil experiment, he used a radioactive element like radium that emitted alpha particles, of which he directed these particles at a piece of thin gold foil surrounded by fluorescent detectors.
An incredible analogy for this experiment is imagine you're sitting in a field. You are then blindfolded and are given a bowl of BBs. To determine what object is placed in front of you, you decide to chunk the BBs at the object and see where it bounces, and hear it too. As it should be, solid objects like a car bounce the BBs back, and hollow objects let the BBs through. As designed in the plum pudding model, the BBs should bounce back because the atomic model of gold is solid, like the plum pudding. However, the outcome was very different.
When they launched these alpha particles at the gold foil, the detectors showed very few bouncing back. Then they noticed that a significant amount of particles just passed through the gold foil, which was previously thought solid. This would be similar to launching the BBs at what you hypothesized was a car, but instead was a chain link.
This led Rutherford to conclude that atoms were mostly empty space, with a dense, positively charged nucleus at the center, which contains protons. It was determined positive because the nucleus protons are positive and alpha particles are positive, causing the certain 1 in 20,000 alpha particles to bounce back. The ratio of particles deflected to particles reflected was very small. This ratio means about 1 in 20,000 alpha particles were reflected. This then deemed particles such as subatomic. This is because they are smaller than the atomic structure and therefore can pass through it.
Thus, this experiment fundamentally changed our understanding of atomic structure, changing our main model of atomic structure from the plum pudding model to the nuclear model. We learned that the atom was mostly empty space full of electrons that allowed for positive particles to pass through. There also was an essential nucleus that was positively charged and in turn reflected the positive particles when in contact with each other. This has been an Age Industries production. Thank you for watching.